I'm going to talk about recursion. Recursion is, you can think of it as an alternative to iteration or using a for or while loop, but it's a way of iterating just simply by using a function to repeatedly call itself. It sounds kind of strange. It's definitely a bit of a mind bender for most people when they see it. But once you kind of learn to love it, it's really useful for certain kinds of problems. I'm going to run through an example that it's not like the most natural case for it. Like I would rather just use a loop for this, but it's just to illustrate, how the mechanics of this work. So I have right now a, a static method that simply takes an array list full of numbers and adds all the numbers up. It returns a sum, that is. So we have, this is all very basic, right? We have a variable where we're going to keep our sort of running sum, right? I'm just calling it total, so I'm going to keep adding in each particular value. I'm using the sort of standard for loop here because now I'll point out how the indexing works, and I'm going to use sort of a similar thing when I go to make it recursive. But we think, we have I is going to start at 0. We're going to add one value at a time each iteration through the loop, and we have this end condition when I is equal to or greater than the array list called numbers in size. So this means the first concept here is, a loop has sort of a starting kind of initial setup, right? We start I at 0, we start total at 0, and it has an end condition. The end condition is when I gets to be too large, right? Once it gets equal to the number size, essentially. Then, so if we have those sort of boundaries on the loop, so we have the kind of initial conditions for it, we have when it ends. Inside the loop, we have, what we want the loop to do each iteration. That is, we're going to take our array list, we're going to use the index I, we're going to look up that value, and we're going to add it to the total. So this is what we want to do repeatedly. And then finally, we return the total. So that's the goal. Now, when we go to do this recursively, I've set up a separate function here. I'm going to do the exact same thing. I'm just not going to use the for loop. I'm going to call this static method recsum from itself. So we'll see. I need to set up the same. I need to keep track of the same information, and I need to keep track and start in the same conditions. So that's what I've already done. So I need to know, numbers, this array list. I need to pass that in. I'm going to keep that same running total. Technically, I could simplify this and get rid of this variable, but I'm going to include it and make the solution a little more verbose just for this, for the sake of the parallelism. So I'm going to keep track of our same running total, and I'm going to use a variable called index rather than just I, but it's going to serve the exact same purpose. Now, so I run my code. It does nothing right now, right? So it's returning 0. You can see that the true sum is 10. I'm returning 0. I just want to show you here that I'm passing in these initial values down here as well. Okay, so I'm passing in the same array list. And I'm starting effectively total at 0 and the index at 0, just like I am for the for loop. So that's important. That's kind of sort of, connection number 1. Has the same initial conditions. I have to specify that. Even though recursion in the second is probably going to look like magic, it isn't really. I'm still specifying all the same things. It's just being sort of operated on a bit differently. So now let me actually implement this. So there's one essential concept for recursion is you always have two types of cases, and it corresponds to, if you think in the for loop terms, the case when you're done. That is, I is now equal to numbers.size, and it's just over. And then every other case between the start and when you're being done. So these two cases are called the base case. I'll write that here. Base case is conventionalist at first, and then the recursive case. Now, you can think the recursive case is essentially, you think it's all the values for i's. For this is 0, 1, 2, da da da, all the way up to being less than the numbers dot size. The recursive case you can also think of as the sort of the general case, the case that you're going to, or the sort of situation you're going to want to repeatedly operate on. So it also, the recursive case is essentially connected to the body of the for loop. So whatever code we're going to write in the body of the for loop, they can think is the equivalent, it's going to be written here in the recursive case. And the base case is the situation where we end. So that means we're done. I'm going to count up with the index just the same. So I'll have my base case if my index is equal to numbers.size. So you can, this is sort of, you can see how this is related to those, not exactly the same as the condition in the for loop, right? So the for loop says while, or for I is 0, I is less than numbers.size. Okay, that guarantees I is going to be 0, 1, 2, all the way up to less than numbers, or rather all the way up to until it's equal to numbers.size. The for loop is essentially saying, here are all the values I want to continue for, effectively. This is saying I'm specifying when I want to stop, right? So you can see how it's related, though not exactly the same. So the base case is when I stop. Else is going to be the recursive case. So I've set it up starting total at 0, index at 0. So they're both situations are starting in the same position. However, we want to and then now they're both ending in the same spot. Now I just need to sort of fill in the body of the logic. So just like in the for loop, when I was done, I want to return total. I'm doing that up here. I'm going to return total. Yes, I'm generally against multiple returns. However, recursion is the exception to this. This is the time to use it. So, okay, we're just going to return the total when we've hit the end, just like we did in the iterative case. Now, we're going to do the same sort of operations. Again, there's maybe some ways of streamlining this if you already know kind of what's up, but I'm going to make everything explicit here. So I'm going to take total. What I'm going to do is I'm going to take numbers, and I'm going to get out the value at the index, just like I do in the body of the loop, because the body of the loop corresponds to the recursive case. That's sort of key. So what are the two things that happen in that for loop up there? Well, we take the value out of numbers and add it into the total, and sort of, it's not quite implied, but it's maybe slightly sneaky, is that at the end here, we're incrementing I. That's the wrong key to press, but yeah, we're incrementing I, the index. So I'm going to go ahead and do that too. Index plus plus. So now we're getting to the really recursive thing is, and this is where it gets a little weird. In the recursive case, I want to add to the total. I want to advance the index, and then I want to move on. So I can think, move to the next, let's say this, index. So essentially the return value of this function in the recursive case is, well, whatever it's saying return whatever we end up with at the end, effectively. So I'm going to pass in numbers, because that's just sort of what we have to pass that along so it has access to all those values. I'm going to give it the new total and the new index, and that's going to be it. So I'm going to save it. Let's go ahead. I have it set up down here. I run it. Presto. It works. Yay. Yeah, so that's it working. You can again, it's a little mind bendy perhaps, but let me dig into this a little bit more. Just to make things clear, I'm going to print out the value of everything. So let's do this. System.out. I'm going to use printf. I'm going to say, let's call it, I'll just say index and total. Why not? I'll state it like this. Maybe it'll be a little clearer. Oh, and I need my new line character. So let's see here. And then let me just run this. So we can see it follows a very it follows the exact same pattern as the for loop. Both the index and the total start at 0, as I've specified down here. We see that get printed out. We realize the index, this is tested to be false. It's not equal to the numbers.size. We move on to the else case. Then we just perform the addition, increment, and advance by calling ourselves. Now we see this line gets printed out. So now we're in the new function call, and you know, the total's been updated to 3 because that's what the first value is. Index is 1. So then on lines 29 and 30, we see we get out, we're going to get out the values 5 and, or excuse me, 2, and then increment the index up to 2. So now when we call this recursive statement, we'll be up here. We'll see the values 2 and 5 appear because we've added 2 to 3 for a total of 5. Now we're on index of 2. Now this is the last value because it's 0, 1, 2. That means we got the number 5. Total is now 10. We advance the index to 3. We move on to the next recursive call. We come in here. We see that now the index is 3. Okay, now that's the number of items in the list. The total's 10, that's the answer. This trips the base case, right? So the index is 3, the size is 3, this is true. Now the value 10 is returned. And there's this sort of, what's the only thing left sort of implied here is this recursive case. You can think it's, you know, return rec_sum, 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 3 layers down. Finally, then rec_sum, we get to the 4th. We hit this case, we return 10, and then it sort of unwinds. So if you can think this is sort of nested 4 layers down, that 10 is returned back and back and back and back and back. So in fact, if I, let's say for the sake of, let's call it final total, let's just do this. So I say the final total is equal to recursively calling onto the next value. I'll do system.out. I'll print printf here, and now we will return final total. Let's go ahead and run this. Ah, shoot, forgot that new line. Put that in here. Let's give that a whirl. So now you can see, so I have the unwind steps. So you see, so that's final total. Sorry, that's my daughter bursting on me. Dinner is apparently ready. So we can see that you see final total 10 or 3 times, and it prints out 10, 10, 10. So essentially, as we go through those first 3 calls, when index is 0, we make this call, and then we come through again. Now it's 1, then 2. We haven't hit line 36 yet because we just keep restarting the method. It's not until we hit the base case, oh, we have the value 10. The value 10 gets returned here at that kind of index level 3 call. We see that printed out. Then that rewinds back up 1 level. We see 10 gets reassigned final total. We see it printed out here. And then it's rewound once more, and then finally once more out to here. So it goes sort of back to itself 3 times, and the 4th time it goes to the main method which called it. I think I'll end this example here. I'll do another video diving a little bit more with a problem that's a little more naturally thought of as recursive. Recursion is a really sort of cool tool to have in your tool belt. Some problems fit really well within it. Adding up numbers is probably not my number 1 choice. I would just use a for loop in this example. So it really comes down to using the right tool for the right situation. Recursion is a little more, let's call it a little more astonishing, or a little, yeah, that's basically the best word for it. It's a little more astonishing to use, so you probably want to use it less frequently. But sometimes it is, just the right tool for the job. And I'll show an example next time where we can sort of translate a mathematical equation straight into code, and it looks pretty nice. But yep, thanks, that's it.